The Four-Day Miracle, the birth of industrial alchemy. On the gray, salt-misted morning of November 12, 1942, the industrial landscape of Richmond, California, witnessed a spectacle that bordered on the supernatural. Amidst the relentless clamor of pneumatic hammers and the blinding arc flashes of welding torches, a behemoth of steel stood poised at the edge of the San Francisco Bay, ready to defy the very fabric of maritime history. This was the SS Robert E. Peary, a Liberty ship measuring a staggering 441 feet in length and displacing nearly 28.5 million pounds of concentrated industrial might. As the vessel loomed over the slipways of the Permente Metals Corporation's Yard No. 2, a hush fell over the assembled crowd of military brass, weary laborers, and cynical journalists. They were gathered to witness a statistical impossibility. In an era where the fate of Western civilization hung by a thread in the shark-infested waters of the Atlantic, this single ship represented a defiant answer to the U-boat menace. The timer had stopped at a figure that sent shockwaves through every naval ministry from London to Tokyo. The SS Robert E. Peary had been transformed from a pile of raw steel plates into a sea-ready warship in a mere 4 days, 15 hours, and 29 minutes. The death of craftsmanship and the rise of the machine. To truly grasp the magnitude of this feat, one must look back across the centuries of maritime tradition. Since before the American Revolution, the construction of a vessel of this scale was considered a work of high art, a slow, meticulous process of handwerk, where master shipwrights and generational craftsmen spent 6 to 8 months shaping a single hull. Every rib was hand-fitted, every rivet was a testament to years of apprenticeship. The sea was a jealous mistress, and it was believed that only the slow, deliberate pace of the guild system could produce a ship worthy of her tempests. Yet, in Richmond, that 1,000-year-old tradition was unceremoniously dismantled. As the SS Robert E. Peary prepared to slide into the bay, the 1,000 workers who stepped back to wipe the soot from their brows did not fit the archetype of the old-world builder. There were no master mariners among them, no men with salt in their veins who had spent decades in the yards of Glasgow or Maine. Instead, the miracle of Richmond was built by an army of the unlikely. Former secretaries who had traded their typewriters for welding leads, Dust Bowl farmers who had fled the failed harvests of the Midwest to find a new life on the coast, housewives and mothers who had mastered the art of the electric arc weld in a matter of 14 days, unskilled laborers who just weeks prior didn't know the difference between a bulkhead and a binnacle. These citizens had been processed through Henry Kaiser's assembly line schools, where the complex mystery of shipbuilding was broken down into a series of simple, repeatable, and mathematically perfected tasks. They were not building a ship, they were participating in a choreographed industrial ballet. A revolution of numbers, the mathematics of victory. This was the exact moment when the mathematics of victory shifted forever. The world realized that the Second World War would not be won solely by the tactical brilliance of generals on a map or the individual valor of soldiers in a trench. Instead, victory was being meticulously calculated in production statistics and logistical throughput. The SS Robert E. Peary was the physical manifestation of a systematic revolution that shattered every existing assumption of the maritime establishment. It proved that complexity could be standardized, 30,000 components could be synchronized into a single flow. Time was a variable, not a constant. The 6-month building cycle was revealed to be a relic of an inefficient past. The arsenal of democracy was limitless. If a single yard could build a ship in 4 days, then no amount of enemy sabotage or submarine warfare could ever hope to empty the Allied supply lines. As the hull hit the water with a thunderous roar, it signaled the end of the craft era and the dawn of the age of mass production. The mathematics of the factory had overtaken the strategy of the battlefield. For the Axis powers, the launch of the Peary was more than just the addition of another cargo ship to the Allied fleet. It was a mathematical death warrant. It was the moment they realized they weren't just fighting an army, they were fighting a machine that could build faster than they could ever destroy. The foundational tremors of this industrial earthquake can be traced back to a single date, December 27, 1940. On that day, the world of naval architecture was invaded by a man who didn't know the difference between a bulkhead and a binnacle, yet possessed an ego and an engine of will that would reshape the globe. His name was Henry Kaiser. At 58 years old, Kaiser was already a titan of industry, a silver-haired, bull-necked construction magnate who had built a kingdom not on the waves, but on the rugged, unforgiving terrain of the American West. Before he ever set eyes on a shipyard, Kaiser had spent his life taming the wild elements of the earth. He was the man who moved mountains and shackled rivers. His resume was written in millions of tons of poured concrete and the redirected flow of ancient waterways. He was the driving force behind the 6 companies, the consortium that had achieved the unthinkable, the construction of the Hoover Dam, the Bonneville Dam, and the colossal Grand Coulee. These were projects of such terrifying scale that they were visible from space, monuments to the idea that nature itself could be re-engineered through sheer logistical force. The Great Maritime Mockery. When Kaiser strode into the offices of the U.S. Maritime Commission and boldly promised to deliver 30 massive cargo vessels for the embattled British government within a mere 2-year window, the reaction from the established maritime elite was one of open, theatrical laughter. To the master builders of the East Coast, men whose families had spent generations perfecting the slow, artisanal craft of wooden and steel hull construction, Kaiser was nothing more than a sand and gravel man, suffering from a profound delusion of grandeur. The industry's skepticism was not merely professional, it was visceral. They saw shipbuilding as a sacred, insular guild. To them, a ship was a living thing, a complex, bespoke masterpiece that required the intuition of a craftsman. Kaiser, by contrast, saw a ship as nothing more than a problem of movement. To him, a 10,000-ton freighter was essentially a bridge that floated or a dam that moved. Even his reluctant partners at the Todd Bath Iron Works, one of the most venerable and traditional shipyards in America, viewed the partnership as an act of charity, or at best a strategic necessity to access Kaiser's massive capital. Their internal memos revealed a staggering condescension. They assumed that their maritime expertise would eventually have to step in and rescue Kaiser from the catastrophic consequences of his own ignorance. They waited for him to fail, certain that a man who spent his life in the mud could never survive in the steel-heavy world of the dockyards. Ignorance as a strategic superpower. What the experts, the admirals, and the master shipwrights failed to comprehend was the most dangerous truth of the Second World War. Kaiser's lack of experience was his greatest tactical advantage. Because he had never built a ship, he was not shackled by the correct way to do things. He was not a prisoner of 3,000 years of maritime tradition. While the established yards were trapped in a cycle of, this is how we've done it since the days of sail, Kaiser looked at a shipyard with the cold, analytical eyes of a dam builder. He didn't see a ship. He saw a logistical puzzle of supply chains and labor hours. He didn't see a vessel. He saw a modular product that could be broken into segments. He didn't see the ocean. He saw a deadline. Kaiser didn't care about the soul of a ship. He cared about throughput. He brought with him the earth mover philosophy. If a mountain is in your way, you don't climb it, you remove it. If a ship takes 6 months to build, you don't hire more master craftsmen. You reinvent the very definition of what a shipyard is. By the time the maritime elite realized that Kaiser wasn't playing by their rules, it was already too late. The naive opportunist was about to prove that in a war of total attrition, the man who moves the most earth and the most steel is the man who decides the fate of empires. The industry laughed in 1940, but by 1942, Henry Kaiser would be the one writing the obituary for their ancient, inefficient traditions.
The death of the rivet, industrial evolution versus maritime tradition. In the early months of 1941, as the shadows of war lengthened across the Atlantic, Henry Kaiser and his brilliant, relentless chief engineer, Clay Bedford, embarked on a pilgrimage to the holy land of American industry, Detroit, Michigan. They stood on the mezzanine floors of the Ford Motor Company's sprawling assembly plants, watching a mechanical miracle unfold below them. Bedford and Kaiser watched as raw steel was transformed into finished automobile chassis in a matter of minutes. They observed a relentless, rhythmic flow. Workers stood at fixed stations while the product moved to them, installing prefabricated components, engines, axles, fenders, that had been manufactured elsewhere in the plant. To the Detroit engineers, this was standard practice. To Clay Bedford, it was a revelation that bordered on the divine. Bedford returned to the California mudflats not just with ideas, but with a radical conviction that bordered on heresy. If the American spirit could build a car every few minutes, it could build a 10,000-ton ship the same way. The ship would no longer be a vessel built by craftsmen. It would be a commodity manufactured by an assembly line. The tyranny of the riveting gang. The first and most violent shock to the maritime establishment was Kaiser's demand to eliminate riveting entirely. For over a century,
The strength of a steel ship was measured by its rivets. This was an ancient, labor-intensive, and incredibly loud process. A traditional riveting gang was a four-man unit of highly specialized laborers. The heater, who stood at a forge, heating steel pins until they glowed cherry red. The passer, who caught the white-hot pin in a bucket and jammed it into a pre-drilled hole. The bucker, who held a heavy steel bar against the head of the rivet from the inside. The driver, who used a massive pneumatic hammer to mushroom the tail of the rivet from the outside. A world-class crew, working in perfect, grueling synchronization, could perhaps install 100 rivets in a day. A single Liberty ship built to traditional specifications required approximately 1 million rivets. The math was a death sentence. At that pace, the German U-boats would win the war before the first American fleet even had its keels laid. The lightning bolt, electric arc welding. Kaiser's solution was electric arc welding. Instead of drilling millions of holes and hammering in millions of pins, he proposed using a high-voltage electric current to literally melt the steel plates together, creating a continuous molecular bond. The advantages were staggering, but so were the risks. Speed. A single welder could join plates faster than an entire four-man riveting gang. Weight. By eliminating the need for overlapping steel plates and millions of heavy rivets, a welded ship was 200 to 300 tons lighter, allowing it to carry more fuel, more ammunition, and more cargo. Labor. You could train a greenhorn to weld a straight seam in 2 weeks. It took years to master the physical coordination of a riveting gang. The establishment in panic. Admiral Land's gamble. When the proposal hit the desk of Vice Admiral Emory S. Land, the formidable chairman of the U.S. Maritime Commission, it triggered an institutional heart attack. Land was a career naval officer, a man who respected the slow, proven evolution of maritime engineering. To him, Kaiser wasn't just suggesting a new tool, he was suggesting a gamble with the lifeblood of the Allied cause. Land's private correspondence, now preserved in the National Archives, reveals a maritime establishment on the brink of revolt. Welding has never been proven reliable for hull construction at this scale, Land wrote. The British Admiralty, the masters of the sea, flatly forbid welding on warship hulls. They fear the brittle fracture. They fear that if one weld fails, the entire ship will unzip like a jacket. Kaiser is asking us to bet the entire American supply line on a laboratory experiment. The smell of desperation. But by mid-1941, Admiral Land realized he had no choice. The mathematics of attrition were turning into a slaughter. In 1941 alone, German U-boats and surface raiders were sending approximately 3.6 million tons of Allied shipping to the bottom of the ocean. The situation was dire. Britain was starving. Food rations were at an all-time low. Oil reserves were measured in weeks, not months. The tonnage gap. Using conventional riveting methods, American yards required an average of 230 days to build one ship. The Germans were sinking them in a fraction of that time. Admiral Land didn't approve welding because he believed in Kaiser. He approved it because he was terrified of the alternative. He smelled the desperation of a losing war. The decision to move forward was not a vote of confidence. It was a Hail Mary pass in the final seconds of a game. Land cleared the way for the death of the rivet, and in doing so, he opened the floodgates for the greatest industrial explosion in human history.
A factory on the mudflats, the architecture of the impossible. Between January and December 1941, a transformation occurred on the shoreline of Richmond, California, that defied the established laws of civil engineering. What had previously been a desolate, marshy wasteland of tidal mudflats, vulnerable to the whims of the Pacific and seemingly unfit for heavy industry, was subjected to a process of industrial alchemy. Henry Kaiser, utilizing the same earth-moving prowess that had tamed the Colorado River, didn't just build a factory, he manifested a city of steel. While traditional maritime engineers spent months drafting proper shipyard blueprints, Kaiser's crews moved with the speed of a desert wind. They drained the marshes, drove thousands of pilings into the unstable earth, and poured acres of reinforced concrete. In less than a year, the Richmond Shipyards stood as a finished monument to the New World Order. But to the old guard of American naval architecture, the site didn't look like a shipyard at all. It looked like a heresy. The assembly line at sea. Traditional shipyards of the era, venerable institutions like those in Newport News or Brooklyn, were characterized by their verticality and their constraints. They were cramped, cluttered spaces where ships were grown slowly from the keel up in a single stationary spot. Kaiser's Richmond yard rejected this entirely. It was designed not by shipbuilders but by logisticians. The layout was a direct translation of the Detroit automobile assembly plant, scaled up to a terrifying magnitude. The prefabrication zones, instead of a small workshop tucked away in a corner, Kaiser dedicated vast open-air plazas to prefabrication. These were massive, specialized subassembly areas where entire sections of a ship were built simultaneously. The parallel building ways, 7 massive parallel slipways stretched toward the water like the teeth of a giant comb. Unlike traditional yards that build 1 or 2 ships at a time, Richmond was designed to process a fleet in unison. The logistical skeleton, the entire facility was crisscrossed by a sophisticated network of heavy-duty railroad tracks. These weren't for standard trains. They were the tracks for the whirly cranes and specialized transport rigs designed to carry prefabricated steel sections weighing up to 150 tons. In Kaiser's yard, the ship didn't just sit, it flowed. Steel entered one end of the yard as raw plate and exited the other as a floating vessel. John Riley and the confidential verdict. In May 1941, the maritime establishment sent its most formidable scout to investigate this Californian madness. John Riley, the chief naval architect for the Bethlehem Steel Corporation and a man with 30 years of blue-blood shipbuilding experience, stepped onto the Richmond mudflats. He expected to find a disorganized mess of amateurish construction. Instead, he found a terrifying efficiency that threatened his entire profession. Riley's subsequent report, marked confidential to prevent a panic among traditional contractors, was a masterpiece of cognitive dissonance. He was a man watching his world disappear. Kaiser has violated every principle of efficient shipyard layout I have learned in 3 decades, Riley wrote with visible frustration. His prefabrication areas are absurdly large, wastefully so by any conventional standard. His crane capacity is excessive to the point of madness. His building ways are too short for traditional fitting. But then the reluctant admission that changed history. Yet, I must admit, the facility is designed for exactly what he claims, the rapid assembly of prefabricated sections. He is not building ships in the way we understand the term. He is assembling them like a child's toy, and he is doing it faster than any man alive. A machine for victory. What Riley saw was the birth of modular construction. In traditional yards, if you needed to install a pipe in the engine room, a plumber had to crawl into the dark, cramped hull of a half-finished ship and work in the shadows. In Richmond, that same plumber worked in a sunlit open-air workshop, installing the pipe into a prefabricated engine room section before it was ever lifted into the ship. Kaiser had realized that the greatest bottleneck in production wasn't the material, it was the environment. By moving the work out of the cramped ship and onto the expansive mudflats, he turned shipbuilding into a 24-hour high-speed manufacturing process. The old guard called it recklessness. The history books would call it the arsenal of democracy.
Democratizing the machine, the great industrial leveling. With the shipyard infrastructure rising from the mud, Henry Kaiser faced a secondary crisis that many experts believed would be his ultimate undoing, the human bottleneck. For centuries, shipbuilding was an insular, almost liturgical craft. Its secrets were guarded by exclusive guilds and passed down through a rigid father-to-son apprenticeship system that could take a decade to master. To build a ship was to be part of a maritime aristocracy. Kaiser, however, viewed this guild system as a relic of a slow-moving past. He didn't have 10 years, he barely had 10 weeks. His solution was to launch a social and industrial revolution that would democratize the very act of creation. He flooded the newspapers of America, from the drought-stricken farms of the Dust Bowl to the crowded tenements of the East Coast, with a siren call that promised more than just a job. He offered a 20% wage premium over standard industrial rates and a radical open-door promise: we will train anyone willing to work. The influx of the unskilled. The response was a tidal wave of humanity. By October 1941, the Richmond yards were swarming with 10,000 newly minted laborers. To a traditional maritime observer, the sight was terrifying. Out of those 10,000 men and women, fewer than 200 had ever set foot in a shipyard. The rest were a patchwork quilt of American life: former school teachers, out-of-work actors, rural sharecroppers, and suburban housewives. To the master builders of the old world, Kaiser was attempting to perform brain surgery with a workforce of ditch diggers. They predicted that these greenhorns would produce ships that would crack under the first wave. But Kaiser understood something the guilds did not. You don't need a master shipbuilder to build a ship. You need a system that makes mastery irrelevant. The pedagogy of the assembly line.
Kaiser's instructors, many recruited from the automotive and pipeline industries, began a process of task deconstruction. They took the monumental, intimidating mystery of building a 441-foot vessel and shattered it into thousands of tiny, manageable pieces. This was the application of scientific management to the sea. In the Kaiser schools, the 4-year apprenticeship was condensed into a 2-week blitz. The instructors didn't teach their students how to build a ship, they taught them how to weld a single specific type of seam. The specialist versus the generalist. A student didn't need to know the physics of buoyancy or the intricacies of engine alignment. They were taught how to hold a welding lead at a 45-degree angle and run a perfect horizontal bead across a deck plate. The repetition of excellence. By doing that one task and only that task 8 hours a day, a former waitress could become more proficient at that specific weld in a month than a master builder who only performed it occasionally. The rise of the industrial everyman. This was the democratization of the machine. Kaiser had successfully stripped away the mystery of the craft. He turned the complex technical requirements of the Navy into a series of Lego-like operations. By the end of 1941, the Richmond Yard was a buzzing hive of Wendy the welders and John the joiners, people who had been told all their lives that they were unskilled, now finding themselves at the helm of the most complex manufacturing effort in human history. They didn't need to be master shipbuilders because the process itself was the master. Kaiser had proven that with the right training system, the ordinary American was capable of extraordinary, machine-like precision. He didn't just build ships, he built a new class of industrial citizens who realized that the master race in Europe was about to be outproduced by the average American in California. Would you like me to continue by expanding the next section, the power of parallel production, to explain how this workforce was organized into a synchronized mechanical ballet?
The power of parallel production, shattering the linear timeline. As the calendar turned to 1942, the world watched in stunned silence as the production curves at the Richmond Yards didn't just improve, they underwent a geometric acceleration that defied every known law of industrial gravity. The statistics read like a countdown to the end of the Axis powers. Kaiser's very first Liberty ship, the SS Ocean Vanguard, had been a laborious birth, requiring 197 days to complete. By the time the 10th ship slid down the ways, that number had been slashed to 97 days. By the spring of 1942, the average construction time across all Kaiser yards had plummeted to a staggering 70 days. This wasn't achieved through simple hard work or longer shifts. It was the result of a profound philosophical shift in how humanity understood the concept of time. The secret weapon was parallel production, a system that murdered the traditional sequential model of shipbuilding and replaced it with a synchronized mechanical ballet. The sequential bottleneck, the old world trap. For 3,000 years, from the triremes of Rome to the dreadnoughts of the Great War, ships were built like houses. It was a linear, vertical process. The foundation, you laid the keel. The skeleton, you built the ribs. The skin, you attached the hull plates. The interior, only after the shell was watertight could you send in the plumbers, electricians, and engineers to begin the cramped, miserable work of outfitting the guts of the ship. In a traditional yard, the ship was a bottleneck. You couldn't install the massive triple expansion steam engine until the engine room was structurally sound. You couldn't build the engine room until the hull was complete. Thousands of workers were forced to wait for the crew in front of them to finish. It was a one-way street of production where a single delay at the keel could stall the entire vessel for weeks. The Kaiser philosophy. Decentralizing the hull. Kaiser and Clay Bedford looked at the ship and saw not a single entity, but a collection of independent modules. They realized that if you could build the components separately, you could build them simultaneously. Parallel production turned the one-way street into a multi-lane superhighway. Under this new regime, the shipyard was transformed into a series of autonomous innovation cells. While one massive crew was on the slipway welding the primary hull plates, other teams were scattered across the sprawling mud flats of the yard, working on entirely different sections of the same ship. The bow section, fabricated upside down on the ground to make welding easier, then flipped by giant cranes. The deckhouse, fully wired, plumbed, and even painted while sitting on a concrete slab a half-mile from the water. The stern assembly, completed with its rudder and propeller shaft housing before it ever touched the main hull. The 8-hour miracle, the big drop. The most dramatic manifestation of this power was the installation of the ship's heart, the 140-ton triple expansion steam engine. In the old world, the engine was built piece by piece inside the dark, echoing cavern of the hull. It was backbreaking work that took weeks of precision fitting in a confined space. Kaiser changed the math. He had the engines built by the Joshua Hendy Iron Works as complete, standalone units. When the engine room section of the hull was ready, the parallel process reached its climax. A massive whirly crane would hoist the entire multi-story engine, already tested and calibrated, high into the air. In a single, breathtaking 8-hour operation, the engine was lowered into the waiting cradle of the ship.
What had once taken a month of sequential labor was now reduced to a single work shift. The result? A flood of steel. By mid-1942, the efficiency of parallel production had reached such a fever pitch that the Richmond yards were no longer just building ships, they were launching them. Because work was happening everywhere at once, the bottlenecks vanished. Worker density. Because crews weren't tripping over each other in a single hull, Kaiser could employ 4 times as many workers per ship by spreading them out across the prefabrication zones. The learning curve. Workers became ultra-specialized in their specific module, perfecting their tasks with a speed that traditional generalist shipwrights could never match. The result was a logistical tidal wave. While the German High Command calculated their U-boat successes based on the sequential speeds of 1940, Kaiser was operating in a different dimension of time. He had decoupled construction from the calendar, proving that if you can work in parallel, the clock is no longer your enemy, it is your greatest ally.
The race for the record, the Industrial Olympics of 1942. By the autumn of 1942, the Kaiser shipyards had transitioned from a desperate wartime experiment into a high-stakes arena of internal rivalry. Henry Kaiser, a master of psychological motivation, had intentionally fostered a fierce, almost tribal competition between his facilities. This was most visible in the Civil War between his own son, Edgar Kaiser, who managed the Oregon Shipbuilding Corporation in Portland, and his brilliant protege, Clay Bedford, who oversaw the Richmond yards in California. What began as internal goal setting quickly transformed into a national public spectacle. The American public, hungry for good news during the dark early years of the war, followed shipyard production speeds with the same fervor usually reserved for Major League Baseball scores. Newspapers across the country ran front-page box scores, tracking which yard had the lowest days to launch average. This culture of competition pushed the workers beyond mere patriotism. They were now fighting for bragging rights and the pride of their respective cities. The 10-day barrier, the Joseph N. Teal. The first major breakthrough in this speed war occurred in September 1942. The Oregon Shipbuilding Corporation announced a challenge that the maritime world deemed suicidal. They would attempt to launch a Liberty ship in just 10 days. When the SS Joseph N. Teal slid into the Columbia River exactly 10 days after its keel was laid, the traditional shipbuilding world was stunned into silence. It was a feat that shattered the previous record by weeks. To the public, it was a miracle. To Clay Bedford in Richmond, it was a provocation. The gauntlet had been thrown down, and Richmond was determined to answer. The challenge: Land versus Bedford. The catalyst for the ultimate record did not come from a rival shipyard, but from the highest levels of the U.S. government. During a high-profile inspection of the Richmond facility, Vice Admiral Emerate S. Land, the hard-nosed chairman of the Maritime Commission, made a casual but cutting remark to the press. While he acknowledged that Liberty ship production had improved, he noted with a shrug that the effort still paled in comparison to the true mass production seen in the automotive or aircraft industries. For Clay Bedford, this was more than a critique. It was a personal insult to the 40,000 workers under his command. He didn't just want to build ships, he wanted to prove that the sea could be conquered by the same logic as the assembly line. He approached Admiral Land with a proposition that sounded like madness. Richmond Yard No. 2 would cut the Teal's 10-day record in half. "Admiral," Bedford reportedly said, "you give us the authorization and we'll show you that we aren't just building ships, we are manufacturing them." Preparation, the 50-piece bow and the staged miracle. The record-breaking attempt on the SS Robert E. Peary was not a stunt achieved through reckless speed, but rather a masterpiece of logistical staging. For weeks, the Richmond Yard prepared in secret. This was parallel production taken to its absolute logical extreme. Before the keelplate was even touched by a crane, the ship essentially existed in its entirety as a series of colossal Lego blocks scattered across the prefabrication plazas. The bow section, traditionally one of the most difficult parts of the ship to build due to its complex curves, the Peary's bow was broken down into 50 individual pre-welded subsections. It was fully equipped with anchor hardware, chain lockers, and even the forward crew's bunks before it ever met the hull. The engine, the 140-ton Joshua Hendry triple expansion steam engine, sat on a specialized transport rig, pre-tested and run in so that not a single second would be wasted on mechanical adjustments after installation. The superstructure, the entire deckhouse, was built as a single 3-story unit, complete with wiring, plumbing, and even a layer of gray maritime paint. The choreographed ballet, 4 days, 15 minutes, 29 minutes. At exactly 1 minute past midnight on Sunday, November 8, 1942, the clock started. What followed was described by witnesses as a choreographed ballet of steel and fire. Over 1,000 workers per shift moved with a precision that eliminated every wasted second. There were no waiting periods. As soon as a crane released a section, a swarm of hundreds of welders descended upon the seams like a living wave.
On Thursday, November 12th, at 3:30 p.m., a weary but ecstatic workforce watched as the SS Robert E. Peary was christened and slid down the launching rails into the San Francisco Bay. The final time, 4 days, 15 minutes, 29 minutes. The ship wasn't just a shell. It was delivered for service just 3 days later, fully outfitted and ready for the Atlantic. Henry Kaiser and Clay Bedford hadn't just broken a record. They had moved the goalposts of human achievement. They had proven that when every component is pre-staged and every movement is synchronized, the constraints of time are merely a suggestion. The impossible had been reduced to less than a work week.
The ideological collapse of the old guard, the death of a 3,000-year tradition. The reverberations of the 4-day launch of the SS Robert E. Peary were felt far beyond the mudflats of Richmond. It was a psychological and professional earthquake that leveled the ivory towers of the maritime establishment. For centuries, shipbuilding had been a closed-shop fraternity, protected by a dense thicket of tradition, guild secrets, and the unshakable belief that a ship was a bespoke work of art. In a single week, Henry Kaiser had not just built a cargo vessel, he had rendered an entire industrial philosophy obsolete. The most poignant evidence of this collapse came from the heart of the old guard. The president of the New York Shipbuilding Corporation, a man whose company represented the pinnacle of prestige, building the Navy's most sophisticated battleships and cruisers, embarked on a quiet, almost somber pilgrimage to Richmond in late 1942. He walked the asphalt plazas, watched the untrained greenhorn workers operating in 24-hour shifts, and observed the modular sections being hoisted like toys. Upon his return to the East Coast, he bypassed the usual corporate optimism and delivered a chilling confidential report to his board of directors. It was a white flag of surrender to the new reality. Kaiser has achieved what our industry considered a physical and mathematical impossibility. He has done this by the simple, radical act of refusing to accept our limitations as his own. He does not view a ship as a maritime mystery. He views it as a manufacturing problem. Gentlemen, we find ourselves at a crossroads. We must either dismantle our 3,000-year-old traditions and adopt his methods of mass assembly, or we must quietly accept our own irrelevance in the modern age. The standardization of the sea. The Kaiser effect spread through the American industrial complex like a wildfire. The resistance of the Maritime Commission melted away as the sheer volume of output became undeniable. By mid-1943, the revolution was complete. 18 major shipyards across the United States, many of which had initially mocked Kaiser's sand and gravel background, had fully retooled their facilities to mirror the Richmond model. This continental shift in production logic led to a statistical miracle that remains unmatched in human history. The tonnage war, the brutal calculation of the Battle of the Atlantic, was being won on the factory floor. The death of the calendar. The average construction time for a Liberty ship, which had begun at a staggering 230 days, plummeted to a national average of just 42 days. The triple launch. America reached a tempo of industrial heartbeat where it was launching 3 full-sized Liberty ships every single day. The defeat of the U-boat. By the summer of 1943, the arsenal of democracy had achieved the ultimate strategic goal. The Allies were building replacement tonnage faster than the combined forces of the German Kriegsmarine could sink it. Logistics as a weapon of war. To the German High Command, this was a development they had failed to account for in their total war simulations. Grand Admiral Karl Donitz had based his entire submarine strategy on the assumption that American shipbuilding was a craft limited by a finite number of master shipwrights. He believed there was a ceiling to Allied production. Kaiser's methods had shattered that ceiling. By democratizing the skill of shipbuilding and moving it to the assembly line, the United States had effectively turned the ocean into a bridge made of steel. The old guard of the maritime world had lost their monopoly on the sea, but in its place they gained a machine for victory. The battle was no longer a question of naval tactics, it was a question of throughput. As the Liberty ships clogged the horizons of the Atlantic, the Axis powers realized they were no longer fighting a navy, they were fighting a factory that never slept. A new social order, the shipyard as a laboratory for democracy. By 1944, the Kaiser shipyards had evolved into something far more significant than mere centers of military production. They had become the most radical laboratories for social engineering in American history. As the earth mover, Henry Kaiser, scaled his operations to meet the insatiable demands of the global war, he inadvertently dismantled the rigid social hierarchies that had governed American life for nearly 2 centuries. At its peak, Kaiser's industrial empire employed a staggering 200,000 people, a massive, diverse army of laborers that necessitated a total reimagining of the American workplace. In an era defined by exclusionary Old World guilds and pervasive racial and gender barriers, the Richmond and Portland yards stood as anomalies of integration. Kaiser didn't diversify his workforce out of a sense of modern altruism, but out of industrial necessity. He realized that to build a ship every few days, he couldn't afford to ignore any segment of the human population. The feminization of heavy industry. The most visible shift was the presence of women on the steel. By 1944, 27% of the total workforce across Kaiser's 7 yards were women. These weren't just clerical workers or support staff. They were Wendy the welders and Rosie the riveters who had mastered the high-heat, high-risk trades of the assembly line. This represented a total inversion of the maritime tradition. Before 1941, the idea of a woman handling an electric arc welder on a 441-foot cargo hull would have been dismissed as a fantasy. Yet under Kaiser's task deconstruction training, thousands of women, many of whom had never held a tool more complex than a kitchen knife, became the backbone of the production line. In the 3 Northwest yards alone, over 31,000 women were pulling shifts on the slips, proving that technical precision and industrial stamina were not biological traits of the master race, but skills that could be taught to any dedicated citizen. Breaking the color bar, a precarious integration. Parallel to this was the rise of African American industrial participation. In the 1940s, much of America remained gripped by the shadow of Jim Crow and discriminatory hiring practices. Kaiser, however, opened the floodgates. Tens of thousands of African Americans migrated from the South in what became known as the Second Great Migration, drawn by the promise of Kaiser's 20% wage premium. In the Richmond yards, African American workers weren't just relegated to the broom and mop jobs of the past. They were trained as welders, ship fitters, crane operators, and even supervisors. While this integration was often fraught with tension and resisted by some established unions, the sheer momentum of Kaiser's production schedule forced a functional integration that was decades ahead of its time. The shipyard became a place where the American dream was hammered out in real time, a space where a man's worth was measured by the quality of his weld rather than the color of his skin. Innovating survival, the birth of Kaiser Permanente. Kaiser soon realized that managing an industrial army of 200,000 people required more than just wages. It required social infrastructure. The workers were living in boom towns like Vanport City, temporary, high-density housing, where traditional fee-for-service medicine was failing to keep the workforce healthy. If a welder fell ill, the assembly line slowed down. To Kaiser, healthcare was not a luxury, it was a maintenance requirement for his human machinery. He partnered with a visionary physician, Dr. Sidney Garfield, to pioneer a revolutionary concept, prepaid group practice medicine. The model, instead of workers paying high fees for individual visits, a small deduction was taken from their weekly paycheck. This pool of money funded dedicated on-site hospitals and clinics within the shipyards. The philosophy, the focus shifted from sick care to preventive care. Garfield realized that it was cheaper and more efficient to keep a worker from getting sick in the first place than to treat them once they were bedridden. The legacy, this experiment on the mudflats of Richmond, became the blueprint for the modern health maintenance organization, HMO. After the war, the system was open to the public, evolving into Kaiser Permanente. Today, the organization serves over 12 million members, standing as a living monument to the idea that the health of a nation is directly tied to its industrial and social well-being. The industrial citizen. By the end of the war, Kaiser had created more than just ships. He had created a new archetype of the American industrial citizen. He had proven that a diverse, mongrel population, when given high wages, world-class training, and integrated healthcare, could outproduce any ethnocentric master race on the planet. The shipyards were the front lines of a social revolution that would eventually fuel the civil rights and feminist movements of the coming decades. Henry Kaiser's greatest invention wasn't the Liberty Ship. It was the realization that a democracy's greatest strength lay in its ability to empower every single one of its citizens to build a miracle. The verdict of history. From emergency tonnage to global standard. When the final surrender was signed in 1945, the global maritime establishment breathed a collective sigh of relief. The skeptics and traditionalists, who had spent 4 years grudgingly watching Henry Kaiser's upstart methods dominate the waves, fully expected the industrial boom to collapse like a house of cards. They believed that once the frantic necessity of war vanished, the world would return to the proper ways of shipbuilding, the slow, artisanal, riveted traditions of the past. They were catastrophically wrong. While the smoke cleared from the battlefields and the production lines at Richmond and Portland eventually fell silent, the DNA of modern industry had been permanently altered. The Kaiser Revolution did not die with the war, it simply migrated. The knowledge gained on the mudflats of California became the foundation for the entire post-war economic miracle. The seed of the Asian economic miracle. The most profound verdict of Kaiser's methods wasn't found in America, but in the ruins of the post-war East. When Japan and later South Korea began the Herculean task of rebuilding their shattered maritime industries in the 1950s and 60s, they reached a pivotal strategic crossroads. They could follow the traditional British model of boutique shipbuilding, slow, precise, and labor-intensive, or they could adopt the American Kaiser model. They chose the latter. The legendary yards of Hyundai Heavy Industries in Ulsan and Mitsubishi in Nagasaki are the direct descendants of Richmond Yard No. 2. They took Kaiser's modular prefabrication, his parallel assembly lines, and his de-skilled training programs and refined them into a science. Today, the fact that a massive container ship can be assembled in a matter of months rather than years is a direct tribute to the earth mover who refused to believe that ships were different from cars. The British shipbuilding industry, which clung to its artisanal traditions for too long, eventually withered, while the Kaiser-inspired yards of the East came to dominate 90% of the world's commercial tonnage. The statistics of a superpower. To look at the final accounting of the Liberty Ship program is to gaze upon the raw, unadulterated power of a mobilized democracy. These figures aren't just industrial metrics, they are the mathematical proof of why the Axis powers never stood a chance once the American factory was fully engaged. 2,710 Liberty ships. This total represents the largest class of ships ever produced in human history. To visualize this, if you lined these ships up bow to stern, they would form a continuous steel bridge nearly 230 miles long. The 1.8 ship per day heartbeat. At the absolute zenith of production in 1943, the United States was launching nearly 2 full-sized cargo ships every 24 hours. For every ship a U-boat sank, American workers were already finishing 2 more. 53 million tons of victory. Between 1941 and 1945, American yards produced enough shipping capacity to transport the entire industrial output of a continent several times over. This was the arithmetic of attrition that Grand Admiral Donitz simply could not overcome. The 5-year immortals. Perhaps the most stinging rebuke to the old guard critics was the sheer durability of the vessels themselves. During the war, the Liberty ships were mockingly referred to as ugly ducklings or 5-year ships. Engineers and traditionalists predicted that the hasty welded seams and crude modular designs would fail within a few years of peace. They were viewed as disposable tissue paper for the Atlantic crossing. History, however, had other plans. The emergency vessels proved to be among the most rugged and reliable ships ever built. Decades of service. Hundreds of Liberty ships continued to haul grain, coal, and machinery across the globe well into the 1970s and 80s, outlasting the finely crafted ships built by traditional yards. The survivors. Today, over 80 years after they were rushed into existence by former farmers and housewives, 2 Liberty ships remain operational. The SS John W. Brown in Baltimore and the SS Jeremiah O'Brien in San Francisco serve as living, breathing museums. The 50th anniversary voyage. In 1994, the Jeremiah O'Brien accomplished a feat that silenced every remaining critic. It sailed from San Francisco through the Panama Canal and across the Atlantic to participate in the 50th anniversary of D-Day in Normandy. It made the journey under its own steam, using the same old-fashioned triple expansion engine installed during the war, proving that Kaiser's speed did not come at the expense of strength. The enduring legacy of the impossible. The final verdict of history is that Henry Kaiser didn't just win a war, he redefined the limits of human potential. He proved that tradition is often just another word for inefficiency, and that the greatest barrier to progress is the word impossible. The Liberty ships are mostly gone now, rusted away in breakers' yards or resting as artificial reefs on the ocean floor. But the modular revolution they sparked endures in every modern skyscraper, every aircraft assembly line, and every just-in-time supply chain that powers the 21st century. The ugly ducklings of 1942 became the golden geese of modern global trade. Henry Kaiser's legacy is carved not in stone, but in the realization that when a free people are challenged to do the impossible, they don't just meet the challenge, they turn the impossible into a standard operating procedure.
The legacy of the impossible, a new frontier of human potential. The saga of the Liberty ships is far more than a dry chronicle of wartime logistics or a footnote in naval history. It stands as a profound, eternal testament to a singular, world-altering idea. Industrial capacity is not a physical limit, but a flexible, conceptual one. Before Henry Kaiser, the world believed that production was governed by the number of master craftsmen available and the slow, linear progression of traditional techniques. Kaiser shattered that glass ceiling, proving that the true engine of progress is not found in ancient guilds, but in the radical reimagining of what a human being, properly organized and empowered, can achieve. Kaiser's greatest contribution to the 20th century was the democratization of excellence. He proved that ordinary people, the waitresses, the field hands, the clerks, and the retirees, could, when given a world-class system and a sense of shared purpose, produce results that had previously been the exclusive domain of elite masters. He didn't just build ships, he built a culture of the possible, transforming the American workforce into an unstoppable industrial force that functioned with the precision of a high-performance machine. The Nimitz verdict, victory by throughput. The strategic implications of this revolution were felt most keenly on the front lines. Admiral Chester Nimitz, the commander-in-chief of the Pacific Fleet, was perhaps the most authoritative witness to this phenomenon. In his post-war reflections, Nimitz bypassed the traditional focus on combat heroics to offer a sobering mathematical truth about the nature of modern conflict. The Pacific War was won in the shipyards of Richmond and Portland as much as on the beaches of Iwo Jima and the waters of Midway, Nimitz observed. Our success was not merely a matter of tactical brilliance, but of industrial inexorability. We replaced our losses faster than the enemy could inflict them. In the final accounting, it was industrial capacity, not just martial valor, that determined the outcome of the struggle. To the Axis powers, this was a terrifying realization. They were fighting a ghost fleet. For every carrier they sank, for every cargo ship they sent to the bottom, Kaiser's assembly lines were already christening 3 more. The war had ceased to be a game of chess and had become a battle of throughput. By turning shipbuilding into a predictable, high-speed manufacturing process, the United States had essentially achieved industrial immortality. They were a nation that could not be bled out by attrition. The philosophy of the outsider. The most enduring lesson of the Kaiser story is the power of the outsider. Henry Kaiser entered the maritime industry as an ignorant interloper, a man who was mocked for his lack of formal naval education and his crude background in sand and gravel. Yet it was precisely this lack of traditional training that allowed him to succeed where the experts failed. Because he didn't know the rules, he didn't know they couldn't be broken. He wasn't burdened by the heavy, invisible chains of the way we've always done it. To the experts, a ship was a masterpiece. To Kaiser, it was a product. To the experts, time was a master. To Kaiser, time was a variable to be optimized. To the experts, impossible was a technical verdict. To Kaiser, impossible was simply a word for a problem that hadn't been subjected to his particular brand of industrial logic yet. The immortal echo. Henry Kaiser left the shipyards of Richmond as the man who taught the world a new language of achievement. His legacy is etched into the very fabric of our modern existence. Every time we see a modular skyscraper rise in a matter of months, every time a new gigafactory scales its production to world-changing levels, and every time a diverse, non-traditional workforce is trained to handle the most sophisticated technologies on Earth, we are seeing the ghost of the Liberty Ship program. The Liberty ships themselves may have mostly vanished from the waves, but the standard of the impossible remains. Kaiser's life proved that when necessity meets innovation, and when we stop asking what a person is and start asking what a person can be trained to do, there is no limit to what can be accomplished. In the end, the ugly ducklings of 1942 didn't just carry cargo across the Atlantic, they carried the blueprint for a future where the human spirit, organized through the power of the assembly line, can conquer any horizon.